Hi everyone, this is Panikumar, Senior Lecturer in Chemistry. Welcome back to our channel. In this video, I am going to discuss about one of the most important named reaction, that is Aldol condensation, right? So here, what does it mean by Aldol condensation, and which type of compounds will participate in Aldol condensation, and all we are going to discuss in this video, right? Without making any delay, let us start our topic, that is Aldol condensation. So which type of compounds will participate in aldol condensation, or that might be called as ketol condensation? Which type of compounds will participate in this reaction means the compounds which are having only alpha hydrogen. The necessary requirement for the participation of the compounds in these reactions is nothing but that is the compounds which are having alpha hydrogen atoms only will participate in this reaction, right? So here this aldol condensation reaction is an example for addition elimination reaction. This is an example for addition elimination reaction. This is an example for addition elimination reactions. Here in this reaction, a nucleophile is added over there. What is added in this reaction? A nucleophile is added over there. And here regarding these alpha hydrogen atoms, if we observe, the compounds which are having only one alpha hydrogen atom will show the addition part. That means they involves in the formation of aldol, right? They involves in the formation of aldol. And the compounds which are having at least two alpha hydrogen atoms, okay, which are having only one hydrogen atom, will form either aldol or ketone. If the compounds are having two alpha hydrogen atoms, they will show elimination, addition after elimination also will be shown by the compounds having two alpha hydrogen atoms, and they will form an alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound is formed if that is having at least two alpha hydrogen atoms. Which type of compounds will show these aldol condensation means aldehydes and ketones will show the aldol condensation. Which type of compounds will show the aldol condensation? Aldehyde and ketones will show the aldol condensation. Here aldehydes are more reactive than that of ketones, because here the electron withdrawing group, what is the electron withdrawing group present in these aldehydes and ketones? That is a carbonyl group. Here the minus I effect is shared to only one chain, that means to the alkyl group which is present this side, that is contributed to whole one part only. But in ketones what happens? The electron withdrawing nature is equally shared between two different chains. So because of this reason, what happens means the ketones reactivity towards this aldol condensation is lesser when compared with that of aldehydes. And another important point you have to remember, if you want to facilitate this aldol condensation, or else let me say ketol condensation in the case of ketones, we need a strong base like barium hydroxide. The ketol condensation cannot be carried out with weak bases. If you want to facilitate the aldol condensation with the ketones, you should use a barium hydroxide like strong base, right? These are the preliminary conditions required for the aldol condensation reaction. What does it mean by aldol condensation? What is the definition, and what is the example, and what is the detailed mechanism for this aldol condensation? In aldol condensation or ketol condensation, the carbonyl compounds, that may be what we can say either aldehydes or ketones, the carbonyl compounds having at least one alpha hydrogen atom, at least one alpha hydrogen atom undergoes addition elimination reaction, addition and followed by elimination reaction to form alpha beta unsaturated compound, to form alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound is called Aldol condensation. Let me explain you the definition again. The reaction of carbonyl compounds having at least one alpha hydrogen atom undergoes addition elimination reaction either in the presence of base, or this can be facilitated in the presence of acid also. Addition elimination reaction to form an alpha beta unsaturated carbonyl compound is called Aldol condensation. Okay, let me repeat again the definition. The carbonyl compounds having at least one alpha hydrogen atom undergoes addition elimination reaction in the presence of a base or an acid to form an alpha beta unsaturated carbonyl compound is called as Aldol condensation. Let me take a simple example. For example, if acetaldehyde is taken, CH3CHO, acetaldehyde is taken. When two different moles of acetaldehyde are treated one with another, when two different moles of acetaldehyde are treated one with another in presence of a base, what happens? Here that forms an alpha beta unsaturated carbonyl compound, that forms an alpha beta unsaturated carbonyl compound, CH double bond CH, simply CH double bond. From here two hydrogen atoms are removed and here the oxygen atom is removed. So here you are having only CH and CH double bond CH3. This is alpha beta unsaturated carbonyl compound. This is what called as Aldol condensation. So if you want a shortcut for this Aldol condensation, what is the shortcut? Simply you just write the molecule like this, CH3, and you write the double bonded oxygen facing this side and you are having a hydrogen here. And this alpha hydrogen atom, I'll write H2HC, C double bond O H, like this I have written. So we can write like this. So from here double bonded oxygen, here oxygen is eliminated. So what happened? Minus H2O. Simply this double bond is formed in between this carbon atom and this carbon atom. Then you will get CH3 CH double bond CH CHO. This is what we can say the shortcut for the Aldol condensation. Let us have an in detailed mechanism for this reaction. Let us have the mechanism for this reaction. So here what happens in Aldol condensation, we are having two different moles of the carbonyl compound. We are having two different moles of the carbonyl compound. One of the carbonyl compound will act as the nucleophile. One of the carbonyl compound will act as a nucleophile and another carbonyl compound is called as a substrate. What are the names for these two different kinds of the carbonyl compound? One is the nucleophile and second one is the substrate. One is the nucleophile and the second one is the substrate. So what happens in stage 1? In the first stage what happens means the carbonyl compound CH3 C double bond OH, let me take the carbonyl compound will react with OH minus. So it is a proton abstractor. Nucleophile is generated by the reaction of a carbonyl compound with the base. So what happens? Simply let me write like this, CH2H. So here this nucleophile abstracts the proton. As a result you will get water molecule over there and then you will get CH2 minus C double bond O H over there. This is what formed. This is the nucleophile formed. The so formed nucleophile will react with the second mole of the carbonyl compound. The so formed nucleophile will react with the second mole of the carbonyl compound. Let me take CH3, C double bond O. I am writing this hydrogen downwards. Here what happens? Oxygen is more electronegative than than carbon. So the pi bonded electron will be transferred to the oxygen. So here you will get negative charge, here you will get positive charge, right? Now the nucleophile will attack the positively charged carbon atom. The nucleophile will attack the positively charged carbon atom. As a result, what happens? Like this, it will be transformed. Then you will get CH3, C, and the released proton will be added over here. OH. Already in this first step you are having proton from water molecule that will be regenerated, H plus and OH minus. This H plus will be attacked at the negatively charged oxygen atom, and then you will get OH, and this CH2 is bonded to this one. You are having already CH here and CH2, C double bond OH. So you just have a look at this molecule. This molecule is having two different functional groups. One is the aldehyde functional group and the second one is the alcohol functional group. So this is called as an aldol. This is called as an aldol. Here what happens? Furtherly, to get the stability from the alpha hydrogen atom, I told here, if two alpha hydrogens are here, from alpha hydrogen atom, another H plus ion will be removed. This CH2 I will be writing as CH. So if H plus is removed, then what happens? These electrons are shifted between these two carbon atoms. Then OH minus ion will come out. Then minus H plus minus OH minus. That means you will get a water molecule here, and in between these two carbon atoms, alpha and beta carbon atoms, CH3, CH double bond, CH, CHO. This is the alpha beta unsaturated carbonyl compound. Right, ma? This is the best mechanism and simple mechanism for the aldol condensation. What happens if two different ketones are taken? If I have taken the reaction between two acetone molecules, CH3, C double bond O, CH3, right, plus CH3, C double bond O, CH3. Two different acetone molecules are given. So I am giving you, I will explain this one using the shortcut. Simply you just do one thing, CH3, just let us write C double bond O this side and CH3 this side. And in the second molecule, write the CH3 molecule as H2HCH, right? C double bond O, CH3. Now what happens here? This double bonded oxygen and H2 both are eliminated in the form of water molecule. And then what happens? A double bond is formed in between the carbon atom attached to the carbonyl carbon and this carbon atom. Then you will get the product. Just observe CH3, right? C, it is having a CH3 too, CH3, and this carbon atom is having a double bonded carbon, double bond, and it is bonded to CH, CH, C double bond O, CH3. This is the product, alpha beta unsaturated carbonyl compound is produced. So in this reaction, we can say, I told in the beginning, only the carbonyl compounds with the alpha hydrogen atom only participates. Okay, if the carbonyl compounds without alpha hydrogen atom are there, they does not participates in the reaction. If without the alpha hydrogen atom one molecule and with the alpha hydrogen atom another molecule are given, that is called as a cross-Aldol condensation. The reaction between two different carbonyl compounds. Okay, the reaction between two different carbonyl compounds is simply called as cross-Aldol condensation. About cross-Aldol condensation we will discuss in the next video. Right? Let us see few more examples for the aldol condensation. Intermolecular aldol condensation, that means if two carbonyl compounds are present in the same molecule, that is called as intermolecular aldol condensation. Like this I am having a molecule, let me say like this I am having a molecule, right? Here double bonded O and here a double bonded oxygen, like this I am having. So this is a alpha hydrogen and this is another alpha hydrogen, this is another alpha hydrogen. So simply I will explain through a shortcut. Let me take either this or this. Here I am taking two hydrogen atoms. These two hydrogen atoms combines with this oxygen and eliminated in the form of water molecule. Now let us see. 1, 2, 3, 4, 5. So a double bond is formed in between this first carbon atom and fifth carbon atom. That means you will get a 5-membered ring over there. What we will get? You will get a 5-membered ring over there. Between the first carbon atom and the fifth carbon atom, okay? Between the first carbon atom and the fifth carbon atom, you are having a double bond. Between the first carbon atom and the fifth carbon atom, you are having a double bond. And this fifth carbon atom is having a CHO group. So you just write C double bond O H. And this first carbon atom is having what it is having? It is having a methyl group, CH3. Simple. This is the intermolecular aldol condensation, right? So if different rings are formed, what is the stability means? 6-membered ring is more stable than 5-membered ring is more stable than 4-membered ring. This point you just remember. And here anion is the intermediate in this reaction. So secondary anion is more stable than primary anion in this reaction. These are the important points you have to remember regarding the aldol condensation. Okay, in the next video we will discuss in detail about crossed aldol condensation, right? The condensation between two different carbonyl compounds we will discuss in the next video. Thank you. Thanks for watching.